Yeah. So I'm still missing a batch of people. I guess I'll dawdle for a few minutes. I hope everybody saw on the announcement portion that I took the 14 people who are on my roll and divided them into 2 segments of the A group and the B group so that we can know who is designated for the 2-week rotation process. I'm still missing a batch of people. Actually, the thing that I wanted you to help me with is something I need to record, actually, not something I need to do live.
Well, still, I may as well move stuff off that for sitting small things about it. But
okay.
What do we do?
Soup.
Okay. What ilk of soup?
Oh, chicken stuff. Look on the stove. Yeah, as reality intervenes between being at home and all that kind of thing. All right. Well, while I'm hopefully waiting for some other people to show up, I am going to run through the schedule that I did post along with syllabus. So, actually, share screen. And all right, so let's have a quick look through the schedule since I finally got it from Dr. McHugh. So last week, that was the 13th. Math review, we talked a little bit about safety. That actually applies more to actually being in the lab for real. We have to kind of run through some of that stuff. Today is the plotting exercise, which is all about using Excel. And then 127, which is next week, the people who are in the A group will be doing the organic molecule lab, and I will be posting a short video, probably about 10 minutes or so, of some further explanations on how you're supposed to go about doing that. I mean, there's instructions on the sheet that I loaded up, but I'm gonna probably make a video to give you some additional instructions on that. A group people will then the following week, the first week of February, actually see me for the first time for real on campus in the lab, which is on the 3rd of February. So that is the absorption spectroscopy lab. So let me scroll down so I can show you what kind of the B group looks like. So the B group is, okay, obviously everybody's doing the plotting exercise this week because we're doing it on Zoom here. But my B people actually will be the people I see first in person, just as is how the rotation that was set up. So the absorption spectroscopy, which is in your lab book, will occur next Wednesday, same time that we're doing this now, 5:30. Takes a couple of hours to do it. So I have 7 people that are designated to be the B group. And let me flounder around on my sheets of paper here. Somewhere I laid my other sheets. Oh, there they are. All right, so I'll go through the B group people here in just a minute. So let me scroll back up. It's not a, I don't have a lot of control over this because part of it has to do with what we prepare in the lab versus where we are in the textbook. So the A group people are going to do the absorption spectroscopy, and then they'll have a week of remote, which will be explanation on the website, a video to watch, and some stuff to fill out. Then you'll actually do 2 weeks in a row. Like I said, I didn't set this up, but we're trying to compensate also for the fact that we're trying to get a certain amount of things done prior to spring break. And then the last thing you'll do before spring break is watch the video and all for the rate law, which is experiment 24. Once you come back from spring break, then it's a little bit more every other week thing. So 34, then Le Chatelier's, which is a mixture of a handout, which I'll be posting, as well as a video. There's the potentiometric one. That one is a titration that we will be doing. Then measurement of pH, which is actually also, it's tied into experiment 18. And then we have molar solubility. And the last actual lab event of the semester is the thermodynamics of borax one. So let me scroll down again. B group people, I actually see you next week. Then we skip a week. Then you get to do vapor pressure of water. And then you'll have 2 weeks in a row of not seeing me, the solutions lab and the rate law lab. And then you'll see me right before spring break. You'll see me on the 3rd of March. When you come back from spring break, you will have the equilibrium of the Chatelier's one, which again is like a video and a worksheet kind of thing. Then you'll see me 2 weeks in a row, and then we skip 2 weeks in a row, and we end with molar solubility. There is one wobble that may occur at the very end here. The people I have as B group, because back up here on the A group, the last one is listed as thermodynamics of borax is on the 21st. I may actually, since that's a remote one, so that one's remote one on the 21st. I may actually bump that one and have everybody do it together on Zoom on the 28th. So I will keep you in the loop about that, but that's the one thing about this particular schedule that I may change. There's a reason for this. The thermodynamics topic is actually rather close to the end of the semester. And if I try to have people doing it by watching the video and all that sort of thing on the 14th, I have a suspicion that's going to be a lot of confusion because we won't have gotten there yet in lecture. So, like I said, I will post it probably as an announcement sometime after spring break, but I suspect that I will move that to the 28th and have everybody Zoom it on the 28th, such that you then have 1 week to finish turning in lab reports, and have them due on like the 2nd or 3rd of May, which is a couple of days prior to the final exam. So like I said, there might be a little change in that very last one there, because I did something similar last semester for, I know that a handful of you had me last semester for lab. We took the very last lab of the semester and I pushed it by 1 week so that it coordinated a lot better with our lecture materials. So chances are that may happen again. All right, questions about scheduling. If you look at the announcements, okay, the people who are listed as A group are Bixler, Feliciano, Lee, Muyano, Peterson, Stone, and Wagner. They are A group. This is all listed on the announcements. You can go back and look. And the people listed as B group are Conte, Guimond, Latito, Neville, Sable, Stratter, and Washington. So those are the people that I will actually end up seeing next week. Questions about our odd schedule. We have a little bit of wiggle room, okay? I have 14 people on the roll. I can't have more than 12 people plus me in the lab. So if one or two people end up missing something, there is a possibility that we could make it up by having you come with the other group. Not easy, but possibly doable. I'm working as hard as I can to make sure that everybody gets at least half face-to-face lab experience for the semester. So questions about our wonky schedule. All right, swapping over then to talk about the math review. And I haven't posted this yet. I got distracted this afternoon, real life events and all that kind of thing. And I will be posting this though, so you can go back and check. This is not something to turn in. This is just something to compare to your answers to figure out if you're basically on the right track. The first set of them ask you to designate how many sig figs are present. So if you have 24.00, the fact that you have a decimal place actually allows you to make sure that you are counting the zeros as sig figs. So that one has 4 sig figs. However, in letter B, both of those zeros are leading zeros. Therefore, they do not count. 3.4 times 10 to the third, we're not really paying any attention to the exponent. We're only paying attention to what comes prior to the multiplication symbol. So just the 3 and the 4, so 2 sig figs. And then the last one has a little mix of the two in that we've got a couple of leading zeros. Those don't count. But we do have one trailing zero, and that gives you a total of 3 sig figs. Moving onward to a little one-step math problems. If you are adding 23.02 and 0.321, your calculator is going to tell you 23.341, but you need to round it to 2 decimal places because in addition, you are only allowed to report your final answer to the smallest number of given decimal places. Letter B is division, 360 and 0.90, okay? Once you divide, you'd end up with 0.400. However, rule of division says least number of total sig figs in a given answer. So you had 3 in 0.360 and 2 in 0.90. You're only allowed to report your answer to 2 sig figs. Subtraction, we're back to the decimal place idea. 22.46 minus 0.12 gives you 22.34, only 2 decimal places. 0.44 minus 0.220, since there is only 2 decimal places in the 0.44, you cannot include a last zero at the end of your answer. Then we've got some exponent stuff. Rule of thumb for adding and subtracting of exponents based upon their multiplication or division. So if you are dividing, you're subtracting your exponents. Remember that you can enter this into your calculator as 1 times 10 squared, or 1 times 10 to the negative third. This is how the easiest way to put it into your calculator. So the first one should give you 10 to the 5th. You're adding them for letter B, so that should give you 10 to the 8th. -2 and -5 as your exponents should give you 10 to the 3rd for letter C. For letter D, 10 to the 8th, because first you're adding your 4 and your 2, and then minus -2. So that's an adding, gives you 10 to the 8th. Now, be aware that on your calculator, there should be 2 separate buttons for the 2 different versions of logarithms. LOG is what is known as log base 10s. LNs are what is known as natural logs, also referred to as log base E. E being a number somewhat like pi. It's one of those numbers that has 2.78, and then it goes on for like 80 more decimal places. So we are using that particular base when we are doing natural logs. Log of 10 to the 3rd, basically the log and the 10 cancel out. You get a 3. The same thing is true in letter F of the natural log and the E basically cancel each other out, and you get minus 1.2. If you take the square root of 9 times 10 to the 6th, you should get 3 times 10 to the 3rd. You are taking both the square root of the front and the exponent. It is what happens in essence. Like I said, use your calculator to do these to avoid just kind of careless math errors. I did the top 2 problems on the back of the page the more straightforward way. The way that logs are supposed to work is quite similar to exponents in that you're supposed to be allowed to add and subtract based upon the exponent idea. Truthfully, though, since you're using your calculator to do the rest of this, you should really just make sure you're entering it correctly into your calculator so that the log of 15, this is log base 10, is 1.18, and the log of 9 is 0.95. The latter portion of the back of that page is just kind of a mixture of logs and anti-logs and making sure you're on the right track for these. If you're doing the log of 0.0053, this is a number less than 1, you end up with a negative value, negative 2.28. Anti-log. Now, depending upon what model and what brand of calculator you have, sometimes you are using the shift key, sometimes you are using the inverse key. It probably depends a little bit on your version of the calculator. So on mine, I would hit shift log negative 2.1 equals, and it would give me 7.2 times 10 to the negative 3rd. Natural log, ln, of 0.234 should give me negative 1.452. Back to reverses again. Anti-natural log, so shift key, ln 1.25 equals 3.5. And then how do you solve if there's an x in your exponent? Well, basically, you anti-log both sides. Think about general rules of math. If you want to undo something, general rules of math imply that you have to do the same thing to both sides of your equals. So when you are doing that, if we're looking here at number 10, if I anti-log the left-hand side, I end up with just 2x. If I anti-log 0.036, I get negative 3.32, and then you can just divide by 2 to find your x. The similar event happens for number 11, if you're doing natural log of 8 equals 0.48. If you take the anti-log of both sides, you get 8x on one side and e to the 0.48, which is 1.62. You then divide by 8 on both sides, and your x should be 0.2. Some of this will pop up again about 4 or 5 chapters from now. We will spend some additional time talking about unknown values in your logs. Now, the last one, oh, phooey. I realized I hit my space bar one too many times. Let's see if I can fix this before I post it. Ah, that didn't work. This is being uncooperative. All right. Maybe I can get this to. Yeah, my space key is being definitely uncooperative. Yeah. All right, the way this is supposed to look, and everything is squunched over to one side, is it's supposed to be when you're trying to figure out the molarity of water. And this is the one where I said, pretend you have a liter in order to make some other things cancel out a little bit better. So they give you the value that water is 0.997 grams per mil. Molar mass of water is 18. And this is where the adding in the milliliter liter thing kind of comes into play to make life a little simpler, is it allows you to make sure that your milliliters are canceling out and your grams are canceling out. And then once you finish your division, you end up with 55.327 or 55.3 moles per liter as your final answer there. That one is messy, and I can't figure out why my tab key won't let me push that particular value off to the side an inch there. All right, questions about the math review. All right, onward to plotting. Let me shut down a couple of these documents so I can open up something different. All right, share screen, this. All right. So this particular exercise is all about giving you some data and showing you how to use Excel, because we need to use Excel for quite a number of things this semester. It makes use of the ideal gas law for the front of this page. So PV equals nRT, and there's some additional information about this that I already loaded to the Canvas shell. If you have 3.26 grams of dry ice, and it gives you a molar mass for it, 44.01, figure out how many moles you have. You should be using 3 sig figs, in part because your gram weight that was given was in 3 sig figs. So give me at least 3 sig figs when you do the math for this. The middle part here uses PV equals nRT to help give you the idea of how are you going to convert this data? As we scroll down, here is the fake data. So PV equals nRT. The pressure is something you are going to be calculating, but you're going to be using the unit of millimeters mercury, which means you end up needing a different R value than we typically used in first semester. First semester, when we did PV equals nRT, we used 0.0821 as our R value because it was based on atmospheres. This time around, we want to do it in millimeters mercury. So different R value, 62.37. For your volume, we're going to assume that this is a 2-liter flask. You will have calculated your moles of carbon dioxide, and it gives you temperatures, but note that your temperatures are in Celsius. Add 273 in order to convert your temperatures from Celsius to Kelvin. Then you are going to have to graph things. All right, so let me swap over to Excel. All right, first, a little conversation about graphing, which involves really strange things. All right, so all I'm getting is glare. Let me pull this out of my sheet, and that will diminish the glare. So here we have a graph. You will notice it has on its vertical axis, on the y-axis, temperature of, or average global temperature. This is done in Celsius. Across the bottom, it has numbers of pirates. So if you look at your data, we have data points where each time you change the number of pirates, you change the number of the temperature for the global warming. So therefore, basically, global warming is due to lack of pirates. Okay, well, why am I talking about this? You can graph anything, okay? Just because you can generate a graph from it doesn't necessarily mean your graph is correct or that the logic or conclusion that you draw from your graph makes any sense. So the idea behind this is we're going to look at some data and figure out how to insert it into the Excel spreadsheets. So this is essentially, why is it not doing this? Hang on, I'm having weird. Weirdness because my Excel spreadsheet was not expanding the way it was supposed to. All right, let's try this again. All right, typical Excel spreadsheet. You can put anything you want into your cells. Sometimes you only want to put names, okay, or information that is words. However, obviously you can't calculate anything when you are doing that. If you have numbers, you can then also use equations. So let me show you some already generated ones of data, and then I will show you how to put data in so that it generates things. And as my spreadsheet is being super slow, come on. All right. As you can tell, I have like an almighty ton of like spreadsheets here. All right. So here is some real world data. Okay. This is actually my data, as in tracking my iron saturation, which I have a lot of problems with. because I do what I do, it makes a lot more sense to me to graph my data in order to keep track of it, which baffles the shit out of my doctors, because when I walk in with 8 journal articles and 6 spreadsheets, they usually stand there with their mouth open. Although I have a few that I've actually seen often enough now that they've kind of gotten used to it. So I have 3 columns here. My data for the graph that you see there is days. Basically, I took the first day that I acquired data and I designated that day 0. I actually used one of these weird apps on a website that allows you to put in dates and it'll calculate how many days for you. So I used that, and then I put my percent iron saturation data in. And then because I like to track it according to the year, then I actually have some dates also. So there's a column here, column C, that's actually not part of the graph. So as you can see, I've got numbers going down here, which are steadily increasing, and I was bad, okay, because I've been working on this recently. I didn't go back and label my axes. It is a good required idea to label your axes, and I will show you how to do it here shortly. But I didn't when I was just sort of looking to see what my data looked like. So I've got numbers up the side and I've got numbers up the bottom. So one of the things I'm going to do here then is I'm just going to get rid of my graph to kind of show you how I'm going to create my graph. And then later I'm just going to invent some data to show you how this works. So this is a 2XY data point graph in that I'm going to highlight from here. So that goes across 2 columns, and then I'm going to drag my cursor down, my little plus sign, and I'm going to drag it all the way down to the bottom of my data. Okay. Once I have it all highlighted, I am going to choose Insert. Okay. Look at the toolbar that appears across the top here. Now, I don't have the absolute latest and greatest version of Excel loaded on my computer, but there's not a lot of differences. There's some really small differences in if you happen to have I think it's the 365 version of Excel. There's a little bit of differences, but not a lot. So look here where I have column, line, pie, bar, area, and scatter. The overwhelming majority of the things that we are doing this semester are scatter plots. So I'm going to click on that. As I click on it, I get 5 more pictures. So look at the pictures. The upper left-hand one is dots and no lines. Then the right-hand one at the top there is dots and lines. I've got curves that don't display the dots as the middle line there. I've got another one that allows you to kind of do lines and dots. And then the bottom one allows you to kind of not really display the dots either. Typically, we are going to choose one or the other of the top line. So I'm actually going to pick the one that has the lines. Ta-da, I get a graph. Now, granted, it doesn't show me my axes labels. So follow my little cursor here, go over to see it where it says chart layouts, and I'm going to choose the first one. Ta-da, now I get ways to label this. So I can click in the box, and I can say that this is percent iron saturation. If I hit my enter key, it will populate it into the box. I'm going to click on my vertical axis, and I'm going to label this percent saturation, so percent sat. Again, hit your enter key. And on the bottom here, I'm going to give the, okay, days as my bottom axis there. So I have done a connect the dots style graph that shows a title. It shows both axes labels, and it shows all of the lines connected. And I can see that, okay, realistically, okay, my blood work shouldn't look like this, okay? I have a really bunch of odd stuff going on, but hey, it gives you great data to have a look at. Most people's blood work doesn't look like this. Mine is pretty weird. Part of my Ehlers-Danlos syndrome problems. But it was a good way to show you basic data. All right, so let me close this file. All right, no, I'm gonna not save it. All right, I'm gonna do new. We're gonna create some fake data here because you also need to be able to use the trend line function. All right, so let's create some fake data here. So we'll create one column that, and this is a little bit similar to the pre-lab that I loaded. We're going to call this concentration. Okay, that is my one column there. And my concentration is therefore also going to show me differences in absorbance. This is related to the lab that my B group people are going to be doing next week, which involves the spectroscopy of 4 different metal solutions. So I'm going to give you some fake data here. We're going to invent some concentration here and say that we have 0.05 and 0.1 and 0.15 and 0.20 and 0.25 and 0.30. All right. That's my concentration data. And let's go back and label this and specify that it's M, okay? M for molarity. So I'm going to pull some numbers out of a hat, which are probably going to be kind of not great data, but that's okay for the purposes that we're using it for. Absorbance values are usually between 0 and 2.0. That is the way the machine that we are going to be using reports them. So we're going to go 0.009 and then 0.106 and 0.130 and 0.197 and 0.240 and 0.310. All right. Absorbance doesn't have a unit. Absorbance is absorbance. Okay. It is a mathematical calculation of how much light passes through a sample. So I'm going to graph my data, and I'm going to choose the one that doesn't have the lines. So insert, scatter, and this time I'm going to choose the very first one. So now I've got a graph, and it has my dots displayed, but there's no line yet. It also, of course, has no labels. So back to the labeling thing. I am going to call this something really simple. I'm just going to call it absorbance versus concentration. Up the side here is my absorbance. Across the bottom here is my concentration in molarity. Actually, I should make that a capital M. All right. So I need a line. Specifically, I need a line that is what is known as a least squares fit. Here's another description. It is a line, a straight line, that passes as close to as many points as possible. Now, you can eyeball this. In fact, the very final part of the exercise for doing this lab actually has you taking some of the data, which you have already graphed by computer, and then graphing it by hand to see how big a difference there is. There will always be a little bit of a difference, but if you're lucky, not a lot. All right, I am going to pick one of my points, and I am going to do, okay, on your touchpad or on your mouse, it's a right-hand click, okay? Scroll down here, and it says add trend line, okay? You get this box pop up. For the overwhelming purpose of what we are doing, most of the things this semester, you are going to be choosing linear. Now, look all the way down here at the bottom of the box. There's a couple of little things that can be clicked or not clicked. We want to see the equation on the chart. So click the box that says display equation. I also would like you to click the box that says display R squared. If you have not had any statistics classes, what does R squared mean? Think about it this way, in that the R squared value calculated by the computer for you, you don't have to calculate it, will give you an idea on how good or how awful your data is. If you're hoping for a straight line and your data is really sucky, your R value will be noticeably under 1.00. Perfect data is 1.00. So I'm going to hit close and see where it has my info now displayed on the graph. Some of the labs that we do this semester, you are going to be using the equation. In fact, on the back page, the second page of the information for this lab, you are asked to calculate, well, if time was 200 seconds, what would the concentration values be? So my line, my straight line, has a slope, because remember, good old y equals mx plus b, because we're doing algebra here. I have a slope of 1.1337. And then my y-intercept is negative, because it's minus 0.0327. My R squared value is not awful, but it's not amazing either. 0.98 is got a little goof to it. And in fact, if you look at the line itself, you'll see that second data point appears to be kind of hovering above the line. So if this was in fact real world data, it probably meant that I had done a kind of not great job on the measurement that I had taken on my second sample there, the 0.1061. It's a little higher than it probably should be. However, this is why we graph data, because it helps to average out small glitches that occur overall. Anything that has an R squared value below 0.95 is getting toward pretty awful. Usually you hope for 0.99 and change. This one is a little bit under. I got 0.98, so it's not awful data. It just isn't great data. All right, let me show you some other things. I can also input formulas. We're talking about the ideal gas law for this particular lab. So I could say, if I wanted to calculate P, okay, and I want to have a value for P, I could do equals, because that tells the computer, oh, hey, I'm about to calculate something. And so N, and then star means multiply, R, star, T, okay? So that's N, R, and T all multiplied together. I'm gonna put parentheses around this, and I'm gonna hit my slash, so I divide, and put V, okay? And so you could enter values for R and T and V and have the computer calculate it for you. Ideally, we absolutely positively need the data and the graph. If you want the computer to do the math for you, if you are good at Excel, you can make use of this function. And the further we go through the semester, the more I will try to coach you along at how to make better usage of the ability of Excel to calculate things. But in the beginning here, we're kind of focusing on generate the data, insert it into the spreadsheet, create a graph with it. All right, let me go back to our assignment page. All right, so here was your data. You're given V. You calculated moles, which was from a division up here at the top of the page. You put all of that into PV equals nRT. Make sure you use that value for R, 62.37. Remember, in the world of gas laws, all your temperatures have got to be kelvins. I will let you skate a little bit. You can just use 273 to convert over to Celsius. You don't have to use 273.15. It won't give you dramatically different data if you round it slightly. And you solve for every different temperature, you get a different pressure. Now think back, okay? In the world of gas laws, there is a relationship. Warm temperatures at a fixed volume will give you higher pressures. This is why you don't throw the spray paint can in the fireplace when you're done, okay? Because it will cause an increase in temperature, which then increases the pressure, and the can isn't changing volume until it explodes. So think about your relationship there. Every time you up your temperature, you should be getting a somewhat bigger pressure in terms of millimeters of mercury. Let's look at the quote unquote backside of the page here. All right. This one is data for a rate law. So they gave you the first two columns of data. They give you time and concentration. Although we have not talked about it yet to any degree, square brackets in chemistry imply molarity, but they kind of gave you both pieces of data here. Not only did they write the hydrogen peroxide in square brackets, they also gave you the capital M to indicate that it was molarity. Take the natural log of each of those 5 data points. You are going to generate 2 different graphs. Now, the first graph, you want time across the horizontal axis, across your x-axis, and you want molarity up the side. But it's not going to give you a straight line. Choose the scatter version that allows you to connect the dots. It will give you kind of a curve, a little bit wobbly curve, but kind of a curve. The second graph, you are still using time, but you are using natural log of peroxide. This one, when you graph, choose the one that I did that has dots with but no line. So create the graph, then go back and tell it to do a trend line. We are using linear fit. Some tips about the bottom bits here. So think about your data. It says figure out what the molar concentration is at 200 seconds. So scroll back up here and look at the data. I can kind of eyeball it a little bit without even graphing it. I can look at it and say, well, at 120 seconds, it was 0.556. This is stuff that's getting used up. So this is why the numbers are going down. At 240 seconds, I used it up from 0.556 down to 0.394. So even before I graph it, I can kind of make a vague estimate and go, well, my concentration needs to be bigger than 0.394, but smaller than 0.556 because it's somewhere in the middle. It's 200 seconds. So it's somewhere in that gap. Keep in mind that if you use the trend line equation, y equals mx plus b, and you put in your value for seconds and you solve for the other variable, you then have to unlog it. You have to anti-natural log it. Otherwise, it will give you really weird data that doesn't make sense. The very last bit down here at the bottom says, do that graph again, only do it on a sheet of paper. Now, if you want to do all of these things and staple them together and hand it in to me the next time you see me in lab, you don't have to submit them digitally, but you can submit them digitally. Okay, here's where the iffiness occurs. I'm not entirely sure how many attachments. Basically, there's 4 graphs here. I'm not sure how many graphs, and plus there's this document, which since it's a PDF, you're going to have to either, I don't know, if you don't have the ability to type on PDFs, which lots of people don't, you may simply have to print it out, write on it, and then either take a picture or scan it. I don't know how many attachments Canvas will allow you to do. So you are perfectly free to turn this in by hand, basically literally print it out and do the graphs and staple the pages together and hand it in to me physically. But I did activate the ability to turn it in digitally on Canvas so that people can do that if Canvas cooperates. Like I said, I'm not entirely sure about how cooperative it is to submit more than one item. But fingers crossed, I'm going to see everybody half a dozen times this semester, every couple of weeks, roughly. So you can hand me stuff in. Yes, I have due dates that are listed. Those are recommended because we're still in the weirdness situation, I'm really flexible about that. I know some of you I had last semester, you have to have it turned in basically by the Monday before final exams, because I have to have a couple of days to finish grading papers. And I'll give you the actual date that everything actually positively, absolutely has to be turned in. But right around the 3rd of May is what we're sort of looking at for that. However, don't get behind. These are extensive labs. If you get behind, you're going to have a lot of problems getting all the math done and the graphs that go with them in order to be able to turn them in. So try as much as you can to keep up. Submit things digitally as much as possible so that I can give you feedback more swiftly. Because if you wait till you give, if you wait till you see me in lab, and then you hand stuff in, it's still probably going to take me another week or so till I can give you feedback if you really missed some big chunk of the information. Because a lot of times I'll put comments and hand it back if you had lots of problems. So somebody asked me, do we do the graph on Excel? Yes, you can print it out and turn it in on purpose, turn it in person. That is perfectly fine. So I ran through the basics. I taped this, which means, of course, I can't access the video version of this until tomorrow morning because it takes Canvas or Zoom or however that interface works about 24 hours till I can even grab the file and download it. I know the couple people kind of came in late. I will be posting the video link for this in a couple of days. It'll be way before next Wednesday, but it might take a couple of days for me to get that done. Those of you that I have for lecture, I got that done this afternoon. I downloaded yesterday's and got it up to YouTube, and it took an hour or two till it was crunched. And then I post the link for that. So that one is now also available for you to watch. I'm trying to keep up as best I can so I don't get too far behind here at the beginning of the semester. Questions? Look at the A group versus B group that is listed in the announcements. Look at the schedule, because everybody who's in the B group, and I've misplaced my papers again. So B group people who I will see in person next week should be Conte, Guimond, Latito, Neville, Subble, Strader, and Washington. So all of those are people that I will actually see in the lab next week. Bring your mask, closed-toed shoes, and if you want your own safety goggles, which right at the moment I kind of recommend, hit Lowe's or Home Depot this weekend. They cost usually $5 or $6, so fairly low price. As my kid carries my cat around in the background. Questions?
If we have large glasses, does that count as goggles?
No.
Okay.
If you have glasses that have relatively large frames or large lenses, what you may have to buy are the ones that are more geeky, okay? The ones that actually have like kind of the rubbery edges to them in order for them to be wide enough to fit over your goggles. But again, they sell those at Home Depot, okay? They like all of the safety glasses that are not, giant welding shield stuff tend to be under $10. So hopefully, and we do have some for you to use, just with all the weirdness that is going on right now with the plague. I noticed that last semester that a lot of people just went ahead and bought their own, especially if they knew that they were going to have 2 semesters of chemistry. But we do have some there to use, and you can wash them and all before you use them if you like. We have soap and all those sorts of things in the lab. Other questions? Some of you I will see tomorrow night for lecture, for Thursday night lecture. Send me questions. Either email address, either the TCC Edu one or the Amoller at Verizon one. Like I said, I don't check the TCC one quite as often, so it might take you several hours till you hear a reply to me. The other one I keep a little bit better tabs on, so I'm a little bit speedier for replies on that. I'm trying.
Someone in chat asked, "Is there a lab report for this lab?"
Yes. Yes. So the page that I was displaying that looks like this. This is the lab report. Okay. There, it's basically, if you were getting this for like as an actual handout, it would probably be a back and a front. My advice is print it so that you can write on it, because Dr. McHugh did not send them to me in doc form. He sent them to me in PDF form, which is supposedly more accessible for the PC crowd versus the Mac crowd versus Chromebooks and Android-based stuff. Supposedly the PDFs are a better fit. So that's why we've been posting some of the lab stuff as PDFs. So yeah, that's the page you're turning in, but it will be with graphs, 4 graphs, 1 from the front, 2 digital graphs from the back, plus 1 handmade graph. Use a sheet of graph paper. I included a link in the module. You can print yourself a single sheet of graph paper without having to buy a whole pack. You don't even actually need a ruler. All you need is a straight edge in order to generate a hand graph. I spend a lot of time, unfortunately, because I'm only seeing you guys intermittently. I spend a lot of time, usually as the semester progresses, running around asking people, have you done this? Have you done this? I haven't got this from you. So just be aware. I tend to be a little more micromanagey about trying to figure out who's given me what as the semester progresses, because this is all just so weird. Some of you I will see tomorrow night. Bye.
And never mind the email. I didn't know I was trying to log into the old link. Like
oh, okay.
And so I sent you an email, so everybody just ignore that.
Okay.
Because I found it.
Okay, good. And like I said, this is recorded. I'll post this recording either tomorrow afternoon or Friday, so that if you missed some stuff at the beginning, you can go back and watch it. And there is an explanation in the modules too. Yeah, somebody put it out. It's like the recordings posts are usually on a page. And I put the YouTube link there because for some reason the Canvas recordings are really, sometimes they don't work according to plan. And a whole bunch of us in the department have just kind of taken to downloading the file, uploading it to YouTube, and then just posting the YouTube link, because that way you can also watch it on your phone if you need to. All right, I will see you guys later.
Okay, thanks. He was funny too. I saw him in the background.
Oh, my kid. Yeah, he's wandering around.
That was kind of funny. When you see the recording, you'll see what I'm talking about towards the end.
Okay.